Sumo Insight Global. The channel to encourage reading, awakening knowledge. History of folic acid and vitamin B12 is one of the most dramatic and fascinating journeys in science. It involves investigations that seemed completely unrelated, spanning human medicine, animal nutrition, and microbiology, until they finally converged to reveal two essential gears of our cellular life. It all began in the 19th century. Between 1849 and 1855, Dr. Thomas Addison provided the first detailed descriptions of pernicious anemia, a disease that, at the time, was fatal. But the mystery went even further back. As early as 1822, a researcher named Coombe described a fatal case of the same anemia and brilliantly deduced that it was caused by some disorder of the digestive and assimilative organs. The great turning point in medicine came in 1926. George Minot discovered the therapeutic value of liver in treating this anemia, a breakthrough so monumental that it earned him the Nobel Prize. Shortly after, in 1927, William Castle demonstrated that the normal human stomach secretes an intrinsic factor, which must combine with an extrinsic factor found in animal protein for the body to absorb the anti-anemic principle. This mystery lasted for 2 decades, until 1948, when Burke and his co-workers proved that the newly isolated vitamin B12 was both the extrinsic factor and the very principle that cured pernicious anemia. While B12 was being hunted down, another line of investigation was running in parallel. In the 1930s, scientists were attempting to purify liver extracts. It was during this time, between 1932 and 1937, that Dr. Lucy Wills described a macrocytic anemia in pregnant women in Bombay. This anemia responded to treatment with Marmite, a commercial yeast preparation. Wills replicated the disease in monkeys and noticed something intriguing. The Wills factor was present in crude liver, but vanished in the purer liver extracts used to treat pernicious anemia. Today we know why. The highly purified extract contained only vitamin B12, while the folic acid had been discarded during the purification process. The chemical engineering of folic acid took years to solidify. In 1943, Stockstad succeeded in purifying pteroylglutamic acid. That same year, 1943, Pfiffner and his team achieved its crystallization from liver. Its complete laboratory synthesis was accomplished in 1945 by Angier and co-workers, who shortly after, in 1946, determined its exact chemical structure. Soon after, in 1948, crystalline vitamin B12 was finally isolated almost simultaneously by Ricks and the Folkers Group in the United States, and by Smith and Parker in Great Britain. In the meantime, folic acid was proving to be a true linchpin in biology. It was vitamin M, which, as Day and his team demonstrated in 1945, cured anemia and gingivitis in monkeys. It was also vitamin B10, described by Stockstad and Manning in 1938 as essential for the growth of chicks. And in microbiology, it was found to be the vital factor for the growth of the bacterium Lactobacillus casei, a substance that Snell and Peterson, in 1940, managed to extract using activated charcoal filtration. This process produced the charcoal eluate. Scientists used the invisible sponge of activated charcoal to trap nutrients from a biological broth, and then applied a specific solvent to wash out and collect the purified vitamin. The definitive name, folic acid, was coined in 1941 by Mitchell and his co-workers, inspired by the fact that they had isolated the compound from leafy spinach. In that same year of 1941, the paths of nutrition and microbiology joined for good when Hutchings proved that the laboratory factor and the avian factor were exactly the same thing. The great irony that modern science shows us is that neither vitamin B12 nor folic acid exists in our bodies or in food in the exact form they were isolated. In nature, they act as unstable and complex coenzymes. What scientists crystallized were stable versions tailored for the laboratory. How these forms act and intertwine within our metabolism and the creation of our blood is one of the most mesmerizing stories in biology. A story that, even after so many discoveries, still has many chapters left to be written. The journey to uncover folic acid and vitamin B12 was a true scientific saga, where medicine, veterinary science, and microbiology came together to save millions of lives. But the story doesn't stop here. Now that you know the dramatic history behind these two discoveries, in our next chapter, we are going straight to the practical side. How exactly do folic acid and B12 act inside our cells today? What happens to the body when they are missing? And, most importantly, where can you find these vitamins in your daily diet, and how can you ensure the proper absorption of each one? Don't miss the next episode to find out how to apply all this science to your health. See you then.